Hello everyone, welcome back to Let's Crack JEE in English, the channel of Unacademy. And I am Jeetendra Dixit. Here is my profile. I did my BTech from IIT Kanpur and I have been mentoring IIT-JEE aspirants for last 11 years. So I teach mathematics, and in this session we'll continue discussion on continuity. I have already taken 2 sessions of continuity. Now this is the 3rd session. So before we begin, let's first quickly discuss about the Plus subscription. All right. As you know, Unacademy is India's largest online learning platform, and you can have 2 types of subscriptions on Unacademy: Plus or Iconic. So when you take Plus subscription on Unacademy, then you get access to daily live classes of all the educators who are teaching on Unacademy, and you also get you can watch their sessions, recorded sessions as well if you miss something. And recorded sessions you can download and watch offline as well. And during live sessions, you can ask your doubts, you can interact with your educator, you can participate in polls. So these sessions are very interactive. Live tests and quizzes will also be accessible to you, so you can attend all live tests and quizzes and all India test series. All right, and all these courses are well structured. That means you can see the schedule of all the upcoming lectures of any educator you want to follow. So accordingly, you can plan your preparation. And so this is unlimited access you get once you get the Plus subscription. All right. These are the subscription charges. You can subscribe for one. Hi Raghav. Good evening. Good evening. You can subscribe for 1 month, 3 months, 6 to 12 and 24 months. These are the subscription charges for 12 and 24 months. Let me highlight: 38,500 for 12 months and 56,000 for 12 months, and you'll get 10% discount. Use this code JEET1. Right now, this is Iconic subscription in which you get all the benefits of Plus, and apart from that, you get a personal coach as well, now who will guide you, an expert who will guide you throughout your exam preparation. Okay, to align your preparation strategy. Your test analysis will be done in a personalized manner, so it will save your time management. Feedbacks will be given to improve your time management and exam approach. Similarly, study planner will also be customized to you. Expert will help you to customize your study plan. Inequalities, Raghav, which inequalities are you talking about? Are you talking about logarithmic or modulus inequalities? In special classes? Trigo, EMGM. EMGM, I think it will be a practice session. So, because in EMGM there's one formula, yes, but I would have covered all the points of EMGM. You can watch it. There will be good questions on EMGM. All right, so these are the subscription charges for Iconic. For 1 year it is 56,000, and for 2 years it is 86,000. All right, you'll get 10% discount. Use the same code. Now this is Unacademy's learning app. You can download it from Play Store. All right, you can download this Unacademy's learning app from Play Store, and you can start attending special classes which are completely free. Anyone can attend special classes. You don't need to take any subscription for that. All right. Okay, so let's begin the session. Hi Raghav, how are you? Hello Vamsi, how are you? All right, so we'll continue. Raghav, if I'll continue on this channel, then yes, surely I'll do that if I continues. Okay, so I don't know about that, how long I will continue. That's a decision of an academy. So as long as I'm taking sessions on this channel, I'll continue this different calculus. All right. Okay, so today I'll give you say this is a very good example. If your fx is defined like this, fx is equal to, I'll give you the example first because they have asked this question in JEE. So whenever fx is equal to x, when x belongs to a rational number, okay, q is a rational number. And 1 minus x when x belongs to irrational numbers. All right. Okay, so Raghav from C, try this one first. First, you guys try it. See if you are getting any answer, then I'll tell you the concept. You have to check the continuity. Find the point where this function is continuous. Find the points where this function is continuous. For all x, you need to find those points where this function is continuous, not discontinuous. Because you can see at any point what will happen if you pick 1. Suppose you are checking at 1. And 1 is a rational number. Then at x is equal to 1, you'll put 1 in this, right? But when you find the limit at 1, that means right side of 1 or left side of 1, then between any two rational numbers, there are infinite irrational numbers. Between any two irrational numbers, there are infinite rational numbers. So if you pick a small interval after 1, then that interval will be mixed of rational and irrational numbers. So your output can be from this function as well as from this function. So it will fluctuate between these two numbers. So that limit might exist or might not exist. Okay, for some particular value of x it might exist, or for many values of x it will not exist. 1/2. Okay, you're saying 1/2. Yes, good, you got it right. Very nice. Right, good one. See, this is y is equal to x line. All right, very true. I'll tell you the concept. This is y is equal to x line, and this is y is equal to 1 minus x line. All right, you can see these two lines meet each other at x is equal to 1/2. Right, at x is equal to 1/2, these lines meet each other. If you pick any other point to check the continuity, say this is the point. Okay, at this point you want to check the continuity. It might be a rational point or a irrational point. Pick any point. Okay, say x1. So x1, say rational. Okay, x1 is rational. So if x1 is rational, this is your fx1, right? This will be x1, then output will also be x1, right? So your output will be x1 if you put in this. But if you check the limit, left or right limit, then it will be either here or here, right? It will be fluctuating between these two numbers, right? So limit, it will be right hand limit is either x1 or 1 minus x1. Now x1, and it is because it is fluctuating at two numbers, right? So it will not exist. It is a fluctuating kind of discontinuity. But if x1 and 1 minus x1 become equal, when will it happen? It will happen at this point, okay, where these two functions meet. So if you check at this point, right hand or left hand limit, then it will be either at this function or at this function, but both are approaching to the same point, right? That means x1 is equal to 1 minus x1. Yeah, and similarly right hand limit also. So here limit will exist, right? So 1/2 is the point where left and right limit will exist. And other than 1/2, there's no point where limit will exist, because x1 and 1 minus x1 will have different values, all right? Yes, oscillating type. Very nice. See, so what is the concept? Concept is this: whenever you have fx is equal to, if I generalize this, fx is equal to gx when x belongs to rational numbers, and hx, any function, you can take any function, when x belongs to irrational numbers, all right? Then f will be continuous. F will be continuous at the points where gx is equal to hx. So where these two functions meet each other, all right, at those points this fx will be continuous, otherwise it will be discontinuous, all right? All right, so like you can take any function, any example like this: 1 minus x square, and suppose 4 when x belongs to rational, when x belongs to irrational, right? So what will be the points where f is continuous? So f is continuous at, what you need to do, you need to equate them. 1 minus x square is equal to 4. Okay, say let's take minus 4. Yeah, so it will be x square is equal to 5, and then get two values. In this case, x is equal to plus minus of root 5. So x is continuous at x is equal to plus minus of root 5, right? So simple. I hope you got it. Yeah, plus minus root 5. Okay, Raghav, plus minus root 5. Now, next point is this continuity of discontinuity of signum function. Okay, so where is this function discontinuous? Signum of fx is discontinuous at the points okay, so signum of fx is discontinuous at x is equal to a if f of a is equal to 0 and limit x approaching to a f of x is not 0. Okay, that means if function is 0 at some point, I'm sorry, and it's not a constant function, basically constant function around a. Okay, it should not be identically 0 around a. So if it is 0 at a and non-zero around a, I mean left side or right side, it should not be 0. It can be approaching to 0, but it should not be 0. Then this function will become discontinuous. All right, like I'm talking about this. I'll give you the example through graph. Say your fx function is y is equal to fx. Graph of y is equal to fx is like this. Say this is the graph. All right. So this point is x1, this point is x2, this point is x3, this point is x4, right? And another example is, okay, so write the option, write in the comment box, Raghav, for first function, how many points are there for this function to be discontinuous? Y is equal to fx according to the graph I have drawn. Now in this case, it is 0 now. What happens with signum function? Signum of fx is equal to plus 1 when fx is positive. Do you know that? And minus 1 when fx is negative, and 0 when fx is equal to 0. Okay, so here this is y is equal to fx and we are talking about y is equal to signum of fx. All right, we need to check the continuity of this function. So if I tell you the continuity, then this part, see, I'm plotting the graph of signum of fx. Okay, signum of fx with yellow color. So this part where fx is positive will become 1, right? This will become 1. This is y is equal to 1. So whenever this graph of y is equal to fx is above x-axis, signum of fx will become 1. This point will be 0 because fx is 0, so signum of fx will be 0. Signum of fx will be 0 here also. Signum of fx will be 0 here also. Signum of fx will be 0 here also, right? Between x1 and x2, because fx is negative, so signum of fx will be minus 1. This is y is equal to minus 1. Then again signum will become plus 1. So at between these 2 points signum will be plus 1. And then again signum will be plus 1 only up to x4. But here it is open. And now it will become minus 1. So it will remain minus 1. Okay. So that is the graph. So clearly you can see, yes, x1, x2, x3 and x4. These are the points where this function is discontinuous. Okay. Now let's come to this. This is y is equal to fx, and now we are plotting y is equal to signum of fx. All right, signum of fx. So this portion will become 1. Okay, at x1 it will be 0. Now it will be minus 1 up to this point x2, and this is x2. Then it will be 0, and again it will become plus on this small interval. Okay, and from this point, because this function is 0, so signum of 0 is 0, so it will remain 0, right? It will overlap with x-axis. But x3 is point of discontinuity because left hand limit is different. All right, after this there's no point because fx is continuously 0. Fx is continuously 0, so signum of fx will also be continuously 0. But x3 will be the point of discontinuity because before that fx was positive, so left hand limit has become 1, right? This left hand limit, right hand limit and value are 0, right? So how many points? In this case 3 points you're getting, right? So 3 points of discontinuity. All right, 3 points. In this case 4 points. And all these discontinuities, these 3 at x1, x2 and x4, at these 4 points this function has jump discontinuity, while at x3 it has which kind of x3? No, not slope is 0. Value is 0 identically, not slope. This is value is 0. When value is 0, it's a constant function, so slope will also be 0. But if value is 1, suppose, then slope is 0, but function will not be 0, right? So mostly signum of fx is very simple. Whenever fx is becoming 0 at some point, there it is going to be discontinuous. All right. But I was just mentioning this point, if it is continuously 0, see, the point is this: if function goes and touches the x-axis or crosses the x-axis, I mean, it is it is 0 for a point, and then it will cross x-axis or maybe come back after touching the x-axis, then it is going to be discontinuous. But if it becomes 0, I mean it merges with x-axis, then it will be constant function around a. Okay, it's not a constant function here. Constant function means it is not 0. Okay, not any other constant. Yes, at x3 it is isolated. Very good. Now you are prepared, huh? Good. Okay, so it's very simple now. Now, what about this function? I'm giving you some examples. You just tell me the answer. Signum of x square minus 1. Tell me the points of discontinuity, okay? Points of discontinuity. Y is equal to signum of x raised to 4 minus 3x square, 3x cube plus 2x square. All right, keep writing the points. Y is equal to sine x signum of mod of sine x for x belonging to 0 to 2 pi, and y is equal to, last one is signum of ln x ln of mod of x. All right, for x belonging to R. Okay, so let's discuss. 3 points in 1. Oh, no, not 3. Why 3? Y is equal to x square minus 1 will be 0 only for 2 points, na? Plus minus 1. You need to check this graph. Y is equal to x square minus 1. It's a quadratic, na? So it will be 0 at minus 1 and plus 1. So this signum of this will be 1. Signum of this will be 1. And signum of this portion will be minus 1. This will be the graph of signum of x. So 2 points only. This plus 1 and minus 1. Okay. Plus 1 and minus 1. Only 2 points, beta 2 points. In second you're getting 4. Alright. Have you understood that there will be 2 points only in the first example? There will be 2 points only. Alright. In the second one, actually, there will not be 4 points, but I'll tell you. Y is equal to, it is this polynomial. I'm just plotting the graph of this polynomial first of all. If you take x square common, it is going to be x square minus 3x plus 2. Okay. So it is x square into x minus 1 into x minus 2. So it has three points where this function will be 0. You need to check the points where this function will be 0. So you're getting only 3 points, 0, 1 and 2. 0 is a repeated root, right? 0 is a repeated root. So you need to figure out the number of points where this function is going to be 0. No need to know the graph in this case. Okay. So in the first one, you should have put this x square minus 1 is equal to 0. You'll get x is equal to plus minus 1. That is your answer. Similarly, in this also, you need to put this is equal to 0. You will get x is equal to 0, 1 and 2. You have got the points. So 3 points. 3, not 4. Okay. Even if you want to know the graph, then I'll tell you the graph also. It is like this. This point is 2. Then, I'm sorry. It will be like this. It will come from infinity. It will touch at origin. And then it will go up. And then it is 2. And then it is 3. Like this. That is the graph. Okay. So how many points are going to be there? Points of discontinuity. This part is going to be 1. Then there will be a isolated point discontinuity. Again 1. And this point is going to be again isolated. And then jump. Minus 1. And then 1. Okay. So this. Okay. Got it? So 3 points. 3 points in this. Okay, now third example. Third. 3.0 pi 2 pi. Okay. Uh, this seems true. So 0, yes, you need to check where this function is going to be 0. Yeah. So 3.0 pi and 2 pi. True. This one is correct. This is your correct answer. So graph is going to look like this. 0 pe it will be 0, and then it will be 1, and then it is going to be 0, and then it is going to be -1, and then it is going to be 0, right? Simple. So yes, 0 and endpoints also are discontinuous. You know the concept of endpoints. Now in this last one, in this last example, you need to tell me the types of discontinuities also. Okay, types of discontinuities. Which type of discontinuity are? Hi Sunil. Infinite type where? How many points first of all? One. There's mod of x. Okay, mod of x. Mm-hmm, mm-hmm, mm-hmm. This is the graph. This is the graph of ln of mod of x. Ln of mod of x. 0 at 0 it is not defined, and because of mod on x, it will be an even function and symmetric about y-axis. Now tell me fast. Oh, this point is 1, this point is -1. What happened, Sunil? All right. See, this part where have you understood this graph of y is equal to ln of mod of x? Have you got this graph of y is equal to ln of mod of x? Hello, hello, Sunil. Okay, so this part will become +1, where ln x is positive. Positive means after 1 and before -1. Okay, it is symmetric. It is symmetric and symmetric about y-axis. Then at 1 and -1, at 1 and -1, it is going to be 0 because ln of x is 0. And between -1 and 1, except 0, 0 pe ln x is not defined. Okay, it is going to be -1 because ln is negative. Now this point is also open. Why this point is open? Because there's no value of log. There's no value of log at x. So signum of log of x at 0 will also not be defined. So 0 pe there is no value. Other than 0, there are always a value. All right. Sunil, don't do that. Okay. I've got your message. So now you can see there are 3 points. All right, there are 3 points. At 1 and -1, they have jump discontinuity, right? Jump. And at x is equal to 0. At x is equal to 0, which type of discontinuity is this? At x is equal to 0. Tell me. Tell me, Raghav. Missing. Yes, this is missing. This point is missing, right? Very good. There is missing point. This point is missing point, discontinuity. And missing point is removable and jump is irremovable, right? Just in case. Sunil, there's no information of JEE 2021, so I don't know. We'll get a notification soon. Might be delayed, might not be delayed, I don't know. Okay, now I'll tell you some important points. See, if fx and gx, okay, are continuous, if fx and gx are continuous at x is equal to a, okay, then f plus minus of g, f into g, or f upon g, okay, provided g is not equal to g of a is not 0, will also be continuous functions, right? So if two functions are continuous, then there's some addition, subtraction, addition, multiplication, or division. Division may provided denominator is not 0, will be continuous, okay? Like sine x is a continuous function, or e raised to x is a continuous function. So if you add them, sine x plus e raised to x, then you can easily say, oh, both are continuous, their sum will be continuous, all right? So there's no problem at all. So you can add or multiply as many functions as you want. Like x square minus 1, it's a polynomial, are always continuous. You can multiply it by sine x, you can multiply it by tan inverse x, okay? Tan inverse of x. So you can see all these functions are continuous functions. X square minus 1 is continuous, sine x is continuous, tan inverse x is continuous. Yes, you should know continuity of basic functions like standard functions. Tan inverse x is a standard function, sine x is a standard function. Polynomials, are continuous and differentiable. So now their product will also be continuous and differentiable using this concept, okay? Now second point is very important. Now this point is very important, very, very important. If f is continuous at x is equal to a and g is discontinuous at x is equal to a, all right? F is continuous and g is discontinuous at x is equal to a, then f plus minus of g, okay, I'm talking about just addition or subtraction, will be discontinuous at x is equal to a. So if one of the function is continuous but the other function is discontinuous, then the addition and subtraction will be discontinuous at x is equal to a, all right? For example, like sine x plus greatest integer of x, right? Sine x is always continuous, right? And greatest integer of x is discontinuous at all integers, right? So that means their sum will be discontinuous, okay? So their sum, so if I call it f function, then f is discontinuous at all integers, right? If one function is continuous and other is discontinuous, then their sum or difference will be discontinuous for all integers. I hope you have got this point. All right, this is a very, very important point. All right, like if I ask you the discontinuity, okay, so let's work on this. I'll give you example. Find the points where f is discontinuous. All right, where f is fx is equal to signum of x square plus x plus 1 plus signum of, just do it carefully. I'm writing a big example, but it will be, if you apply the concept clearly, okay, then it is not going to be tough. One moment. This is 6. All right. Plus I want to add one more function. Okay, that's it. Oh, okay, sorry. No, one more function. Greatest integer of 1 upon x plus 1 the whole square plus 1. This might be slightly difficult. Shall I remove this? No, okay, I'll remove this last function. We'll discuss it separately. Okay, you just answer this much. That's it. Continuity of all the basic functions. Raghav. All the basic functions means all trigonometric functions. Graphs of all basic functions. The graphs of basic functions, domain and range, you should know. Okay, like polynomials, rational functions like polynomial upon polynomial, or trigonometric functions, inverse trigonometric function, logarithmic function, exponential function, greatest integer function, modulus of x, greatest integer of x, fractional part of x. All right, these functions. Transformation of graphs will start from maybe 26th, 25th or 26th. All right. Five sessions I have planned. Follow those 5 sessions, you learn transformations perfectly. Okay, this is the last example today, so I'll end this session here only, and I'll continue it tomorrow. So do it fast, do it carefully. Oh, I have another class today at special class at 9 o'clock, doubt class. We'll have a long session some other time. Anyways, it was a 1 hour session. Have you got the points? Have you got the points, Raghav? Tell me. हाँ हिंदी से कराएंगे. You are from DPS, right? Okay, see, this x square plus x plus 1, okay? This is more than 0 for all values of x belonging to real numbers, right? Always positive. Because this is always positive, so that's a doubt class basically. Special class is a doubt class. So signum of x square plus x plus 1 is equal to 1 for all x, right? For all x. That means it is always continuous. The first function is always continuous. Now let's discuss this one. X square minus 5x plus 6. This is equal to 0 when x is equal to 2 and 3, right? 2 or 3. So that means it is the signum of this function will be discontinuous. So this is discontinuous at x is equal to 2 and 3. All right, 2 points. Simple. The last one. So this 1 upon ln mod of x, this function is discontinuous at the points where ln of mod of x is not defined, first of all that point, and ln of mod of x is equal to 0, because if denominator becomes 0, then obviously 1 upon 0 is not defined. Okay, so एक point तो हो गया 0, x is equal to 0, right? Because ln of 0 is not defined. Second is ln of mod of x is equal to 0 when mod of x is equal to e raised to 0 and x is equal to plus minus of 1. Okay, so you'll get 3 points, 0 and plus minus of 1. So at x is equal to 0, ln of mod of x is not defined, and for plus minus 1, denominator will become 0. So 1 upon ln of mod of x will become discontinuous, right, at these points, because function will not be defined. And other than that, there's no problem, because ln x is a continuous function and non-zero. So 1 upon ln will also be continuous function. Okay, as I told you, fx upon gx will be continuous provided gx is not 0. Okay, so ln of mod of x will not be 0 for any other point except these 3. Okay, so we have got 3 points for third function. Now see, if I talk about 2, then at x is equal to 2, you can see first is continuous and third is continuous. So first plus third will be continuous for x is equal to 2, but second is not continuous. So that means their sum will not be continuous at 2. Same logic for 3, same logic for 0. For 0, third is discontinuous, but first 2 are continuous. For plus minus 1, third is discontinuous, but first 2 are continuous. So their sum will be, so overall there will become 5 points. Okay, so 5 points. 5 points. X is equal to 0, plus minus 1, 2 and 3. Got it? Got it, buddy? All right. Okay, then I'll see you tomorrow. Okay, tomorrow we will most probably finish this continuity. Okay, we'll finish it. Then we'll start differentiability. There are some important points about product. Also, I'll tell you about tomorrow, about product of two functions. Like summation fx plus gfx, one is continuous, other is discontinuous. Similarly, for product also, there's very important point. So that point I'll tell you tomorrow. Okay. All right, chalo. Good night. Okay. Good night. Bye bye. Take care.